Okay, we're going to talk about the layers of the crust, and the first layer we're going to talk about is the lithosphere, and this is the solid upper and crust part of the mantle. It's just a basic rock structure right there, okay, and that's called the lithosphere. It contains all the plates on the Earth, and we'll talk about the plates later. The next part is the mantle, and it runs from the top right down to here, and that's this part in here. It's part solid, part liquid, and the asthenosphere is in there. And that's what the lithosphere floats on. It's kind of melted rock. It's like, like pudding or something, real hot pudding, let's put it that way. Then the next part is the core, and that runs from here to here. There's two parts of the core. The outer core, which is liquid, and the inner part, which is solid, and it's all nickel and iron. It's melted. And the last part is the crust, and that's this right in here. Now the crust can have water on it, so it can be oceanic crust, or it can just be solid, and that's continental crust. Either way, it's the crust. Structure of the Earth. This is the crust right there, the little tiny spot right up there. Not this whole brown thing, but just that tiny part, real tiny. And then the upper mantle, and that's this part in here. Okay? And it's pretty much solid. It starts to turn liquid in the lower mantle here. That's where everything floats on. Outer core is right here, liquid outer core. Okay, iron and nickel. Then the inner core right here. And that inner core is solid, pushed together real tight. It's like you take a piece of bread and squeeze it. Iron and nickel too. Okay, you got the four layers, the crust, the very top part, the upper mantle, the lower mantle, and the core. And the core has two parts, inner and outer. Okay, so the Earth's crust comports four different layers. The crust is the part that we live on, whether we're on water or land. And then underneath it's the mantle, and it starts to get hotter. And then the inner part is the core, and you've got the outer core and the inner core, and it's pressed together, and it's really hot, but it's still liquid until you get to the middle, and then the inner core is solid. Okay, the crust is the outer part. That's what we live on right there. And the crust is like the skin of an apple or the eggshell of an egg. And it's real thin compared to the other layers, and we've never gone through the crust, drilled through it. Can't take a drill and go through it, doesn't happen. It's about 3 to 5 miles in the ocean because you got the water and stuff, and it's thinner crust, but the land or the continents about 25 miles thick, so there's no way you can get a drill to go through that. And the lithosphere is the upper part of it, and it's broken into plates, sort of like if you had an egg and you boil it and then you crack it. You got those little shells on the outside. That's what the lithosphere plates are. And it's the crust of the Earth that's broken into many pieces, and they're called plates. And they float upon this semi-rigid, kind of soft, mushy stuff called the asthenosphere, and they keep moving along. And this is what it looks like. This is the ocean crust right here, continental crust, and so this would be the water. This is the thick stuff. This is the less dense stuff, and underneath there's usually some rigid mantle there. But this is the asthenosphere. That's the actual kind of like plastic melted stuff, and it flows, keeps moving, and the stuff keeps moving on it. So the asthenosphere is not solid. Okay, and again, the lithosphere, it's the upper crust, and the it's rock, and then it's rock here, and then it's liquid there, but it's still rock underneath. Okay, the mantle is basically the largest layer of the Earth, and it goes from here all the way to the inner core, and it's where the asthenosphere exists right there, and it's the thing that causes that upper crust, the lithosphere, to actually move, and you have continental drift. Okay, the way you get that is that it heats up, becomes less dense and goes to the top, cools down, becomes more dense, goes to the bottom, heats up, goes like that. So this is turning all the time, and the plate on the top is moving with it. So the mantle basically flows because of that current, okay? That convection current, the heating up and cooling down. And so it rises and sinks, and rises and sinks, and it just repeats all over. And as it does it, it takes that plate with it, moves it. Doesn't move it much, but it moves it. And this is what a convection current would look like if you had a piece of cork in there. It heats up, the water does, cools as it gets to the top, then cools, becomes more dense, goes to the bottom, heats up, and as it does that, it moves the water in a circle. And we'll do a lab on this, showing you how rice would move when you got it. So, and that's called a convection current, and you know, it just shows how the asthenosphere, which would be the liquid part, circles there, and as it does, it moves the plates with it. Now, and this can happen in air too. When you have hot air, it rises, cools, and comes down, and you get a convection current there. So when we actually do that, you don't get the boiling water, just be too close to your face. Okay, the outer core is right below the mantle. That's this stuff here. And it's liquid iron and nickel. And, you know, it's pretty thick liquid, but it's still liquid. It's not like, you know, pouring water. And so, you know, it's like real hot metal in there, and it's just all melted, and that's it. Then obviously you got the inner core. And the inner core is right in the center. It's like compressed, squeezed together, and it's basically a solid. And, you know, like I said, it's like taking a piece of bread and you squeeze it and squeeze it and squeeze it till it's real tight, and that's basically what the inner core looks like.